value in A must be mapped into a value in of B, which it is, okay, that's important, okay. And then the second thing is this, is that we can't have any double arrows leaving values in A going to separate values in B, if that makes sense. And in this case here, well, there's no double arrows leaving any single value in A, so hence that's a function. With respect to with respect to G, is G a function? Well, you can see that every value in B is mapped to a value in C, and also we don't have a situation where we have two arrows leaving a single value in B going to different values in C. So we don't have that situation, so G is also a function, okay? So this is what we mean by the composition of functions G after f. What we do first of all is we apply f on its domain, okay? In other words, we map every single value to a particular value in its codomain, okay? So every value is mapped into a value in the set B. Not every value in B needs to be mapped into, okay? The codomain is what's known as the overall set. The range is the actual values that these values are mapped into, okay? So we can see that. And then what we can also see is that with respect to G takes values, it takes every value in B and it maps them into values in C, okay? So first thing that happens is we apply f, okay? Then with the values in B, we apply G, okay? And the question is, what is G after F? What is G after F? Well, G after F is all of the mappings, all of the ways we can get from here across to here, if that makes sense. So that's what G after F is all the ways, all the routes that we can go from here all the way through to C, if that makes sense. Now, in our particular case here, okay, what we can actually see is that, well, let's just write it down, okay? Let's write it down. So let us note, okay? Well, what we're going to note, well, we know that 1 is taken to A, okay? So 1, the value 1 is mapped into the value A, okay? And what else happens? Well, 2 is mapped into the value D, so we have 2 is mapped into the value D, okay? We have 3 is mapped to the value B, so we have 3 is mapped to the value B, and we have 4 is mapped to the value E, so we have 4 is mapped to the value E, if that makes sense, okay? And what else then do we have? Okay, what happens then with these values is the question, okay? Where do these values go to, okay? Well, where do these values go to? Well, A is taken to 7, so what we have here is that A is taken to 7, okay? What else have we got? We have B. Well, B is taken to 9, so B is taken to 9. So here we go. So B is taken to 9. Okay. We have C is taken to 8, but there's no C in this particular set here. Okay. So there's no C in this particular set. Okay. What about D? D is taken to 7, so D is taken to 7. Okay. What about E? We have E is taken to 8, so E is taken to 8. Okay. So what we really have now is we have a function, okay, we have a function that maps the values A, okay, this is the function f here, okay, this is the mapping f and this is the mapping g, okay. So this particular function, which is the function g after f, okay, so g after we do f, okay, well, we have g after we do f is a function that takes, well, it takes all these values, all of these values come across here from the domain, yeah, so it takes every single value in A, so every single value in A is mapped into, well, it's mapped into 7, 7, 9 and 8, so it's mapped into 7, 8 and 9, so that's every single value in C, so we actually have a mapping here, okay, if that makes sense, and g of f now is our function, yeah, okay. So that's actually what a function is. A function, sorry, that's what composition of functions are. It's simply a mapping. It's a mapping from one set into a third set where we go through some intermediate values. One of the really important things about our composition of functions is this, is that when we define our functions, okay, when we define our functions, okay, there's our definition of our function, and here, okay, when we define our functions, okay, what's really important is this, is that the codomain of the first function, let me just get a different color marker here. Okay. The codomain of our first function is the same as the domain of our second function. That's really, really important for us when we do composition of functions. Okay. if that makes sense. Okay, let's have a look at another example. Okay, we'll continue with this in this particular situation, with this particular scenario. Okay, so let's have a look at another example. So let's say we have something like this. Okay, so let's say let A equal the set 3, 7, and 4. Let B equal the set 2, 5, 6, and 9. And let C equal the set, let's say the set 7, 6, 5, and 4, okay, for argument's sake, okay. And let's define, okay, define F to be a mapping from A into B, and G to be a mapping from B into C, okay. Let them be functions, okay, okay. Let them be functions, okay, where they are defined, where they